This is an artist's impression of the quasar 3C279. This quasar, as illustrated here, has a mass of over 1 billion suns and is located about 5 billion light-years away. Even more distant quasars have been found, but have exceedingly high masses that challenge our conventional view of cosmology. Image credit ESOM Cormesser. Out in the extreme distances of the universe, the first quasars can be found. HEO 435-1223, located in the center of this wide-field image, is among the 5 best-lensed quasars discovered to date. The foreground creates 4 almost evenly distributed images of the distant quasar around it. Image credit ESA Hubble, NASA, Suyu al. Supermassive black holes at the centers of young galaxies accelerate matter to tremendous speeds, causing them to emit jets of radiation. While distant host galaxies for quasars and active galactic nuclei can often be imaged in visible infrared light, the jets themselves and the surrounding emission is best viewed in both the X-ray and the radio, as illustrated here for the Hercules A. Image credit NASA, ESA, S. Baumann CODRIT, R. Purley and W. NRAOAUINSF, and the Hubble Heritage Team's Tistraura. What we observe enables us to reconstruct the mass of the central black hole, and explore the ultra-distant universe. The farther away we look, the closer in time we're seeing towards the Big Bang. The newest record holder for quasars comes from a time when the universe was just 690 million years old. Image credit Ginny Yang, University of Arizona Redahan, Fermilab M. Newhouse NOAOAURANSF. Recently, a new black hole, J13420928, was discovered to originate from 13.1 billion years ago when the universe was 690 million years old, just 5% of its current age. As viewed with our most powerful telescopes, such as Hubble, advances in camera technology and imaging techniques have enabled us to better probe and understand the physics and properties of distant quasars, including their central black hole properties. Image credit NASA and J. Barkal IASL NASA, A. Martel JHU, H. Ford JHU, M. Clampin STSCI, G. Hottig STSCI, G. Illingworth Bucolic Observatory, the ACS Science Team and ESAR. It has a mass of 800 million suns, an exceedingly high figure for such early times. This artist's rendering shows are being cleared of interstellar gas, the building blocks of new stars. Winds driven by a central black hole are responsible for this, and may be at the heart of what's driving this active ultra-distant behind this newly discovered quasar. Image credit ESAATG Media Lab. Even if this black hole formed from the very first stars, it would have to accrete matter and grow at the maximum rate possible, the Eddington limit, to reach this size so rapidly. The active Iris F1111932557 shows, when viewed up close, outflows that may be consistent with a major merger. Supermassive black holes may only be visible when they're turned on by an active feeding mechanism, explaining why we can see these ultra-distant black holes at all. Image credit NASA's Goddard Space Flight Center's DSSS. VAU. Fortunately, there are other ways to grow a supermassive black hole. When new bursts of star formation occur, large numbers of massive stars are created. The visible Niara photos from Hubble show a massive star, about 25 times the mass of the Sun, that has winked out of existence, with no supernova or other explanation. Direct collapse is the only reasonable candidate explanation. Image credit NASAESAC. Koch and Ekosu. These can either directly collapse or go supernova, creating large numbers of massive black holes which then merge and grow. Simulations of various gastric processes, such as mergers, indicate that the formation of direct collapse black holes should be possible. A combination of direct collapse, supernovae, and merging stars and stellar remnants could produce a young black hole this massive. Image credit Elmaya al. 2014, via http://successive.org ads 1411.5683. Only 20 black holes this large should exist so early in the universe. An ultra-distant quasar showing plenty of evidence for a supermassive black hole at its center. How that black hole got so massive so quickly is a topic of contentious scientific debate, but may have an answer that fits within our standard theories. Image credit X-ray NASA Cuff Kuniv of Michigan R.C. Rice al optical NASA's Chi. Is this a problem for cosmology? More data will decide.